So structural equation modeling using smart PLS. I was already introduced to Uduakobong to PhD. That's my name. I happen to be the quantitative data consultant for Academic Hive. So we'll just go step by step. And I will say, please, if you have any question in the course of this teaching, do well to write it down, or you can drop it in the chat so that after this, the recording will be paused and then I'll address any form of concern that we have. Thank you very much. So it's a very detailed slide. I will be speaking with the slide, and at some point I'll pause and just be explaining some things before we move to the hands-on training. So structural equation model, known popularly as SEM, is a general modeling framework that integrates a number of different multivariate techniques into one model. Different multivariate techniques into one fitting framework. That's the beauty of SEM. SEM is a framework that draws from different disciplines. Measurement theories from psychology. Factor analysis is gotten from psychology and statistics. Path analysis is gotten from epidemiology and biology. Regression modeling is from statistics. And simultaneous equation is gotten from econometrics. All of these techniques put together makes up SEM. All of these techniques put together, the path analysis, the factor analysis, the regression model, all of this put together makes structural equation modeling. So structural equation modeling is well known for its ability to address multifaceted and complex research questions. No matter how complex your research question is, that you have the moderating variable, you have the mediating variable, or there are some models that you will see the moderating and the mediating variable both in the same model. This is the best statistical technique to solve. Structural equation modeling consists of 6 basic steps: model specification, identification, estimation, evaluation of model fit, model modification, and reporting of results. Model specification. How do you specify your model? First of all, from your research objectives, you can clearly specify your model. Y equal plus A, B, O, and all of those things. The statisticians will understand better. And then we come to identification. You identify each of the variables in your model. Which one is the independent variable? Which one is the moderating variable? Which one is the mediating variable? Which one is the dependent variable? You know each and every one of them, because if you don't know them, if you don't have a good understanding of your variables, then it will be a bit difficult for you to draw your model. Yes, it will be a bit difficult for you to draw your model. Then we talk about estimation. Estimation is also statistics, where you actually design, or you actually outline your statistical model. And then what is coming in first, what is coming in second, and what is following till you get to your last variable. Then you evaluate your model fit. I mean, when we go to the hands-on training, you will see how structural equation model with smart PLS will do this for you easily. This model fit evaluation, it will do it for you effortlessly. You don't need to crack your brain about this. With just a click of a button, and this will be done. Model modification, and if for any reason you have probably your output is not what you were expecting, and you want to modify that model, probably reintroduce a variable or take out a variable, or you want to see how to introduce a variable that can mediate that relationship, or that can moderate the relationship between the independent and the dependent variable. All of this can be done. And after every one of this, you can now talk about reporting of results. At a click, there is the output is in front of you, and then you export it to your Microsoft and you start reporting. So conducting SEM analysis requires certain data consideration, as data-related problems are often the reasons for software failures. For those of us that have used analysis of movement structure, that's EMOS, you get to discover that if your data is not neat enough, it will run. EMOS will give you error message. It will not just run the analysis. That's why most people run away from structural equation model, because before you can even think of running a SEM analysis, you must be sure that your data set has met the basic assumptions. Your data set, the normality, the linearity, the homoscedasticity, and everything. But the beauty of Smart PLS is it handles the issue of missing value. If you use a data set with missing value to run SEM in EMOS, it will run. But then if you bring it to Smart PLS handles the issue of missing value already. So Smart PLS is identified with different names. Sorry, structural equation model. It's the workshop is about Smart PLS, so it will come into my mouth every now and then. Structural equation model is identified with different names in existing literature. So when you go online and then probably you download a research work and you get to see some of these names, some of these nomenclature, just know that it has something to do with structural equation model. The first one is covariance structure analysis. The second one is analysis of movement structure. That's EMOS. But this is the full meaning of very popular software that people know is LISREAL, but the full meaning is analysis of linear structure relationship. Analysis of linear structure relationship. Sorry. And then we have this. Analysis of linear structure relationship. These are the basic three names that you get to meet when you're going through research work online. You just see covariance structure analysis, analysis of moments structure, and analysis of linear structure relationship. So we move to the next slide. Researchers use structural equation model in different areas like testing and development of theory. So structural equation model allows researchers to test theoretical models by examining the relationship between constructs, the independent variable and the dependent variable. This is done with structural equation model. Unlike traditional regression, SEM can model entire system of interrelated hypotheses simultaneously, helping to confine, refine, or reject theories. So unlike the popular regression where you have just independent and dependent variable, you can have a model that can bring in a moderating variable or can bring in a mediating variable. You can even bring in a control variable, so far as you can model it in your objective. So far you can have your model very straight. SEM is the best tool that will run that analysis for you. And the one thing I love about Smart PLS software is it helps in this model design in such a way that it makes it very easy. With just a click, just click, and then the model is designed for you. There are some softwares that you will need to sit down and draw the model yourself. I mean, one of such software is EMOS, but Smart PLS doesn't need you to draw. Just click and then the model is designed for you. All you need to do is know your variables. What is your independent variable and what is your dependent variable? Where do you place your independent variable and where do you place your deviation? Through Confirmatory factor analysis. I mean, some of us have heard of CFA, confirmatory factor analysis. SEM is used to validate measurement instruments, ensuring that survey items or test components reliably represent underlying theoretical constructs. This has a whole lot to do with validity and reliability testing. Validity and reliability testing. When we go to hands-on, you get to see the AVE, average variance extracted, and the different types of reliability, the Cronbach alpha and the rest of them. It's quite easy for you to use them to ensure that there is your research instrument which is not meeting the threshold. You can just easily take it off, and it will show you. I love the way the SEM model brings it out. It shows you the individual contribution of each observed variable as to the Latin variable. So you now see which one contributes the highest and which one contributes the lowest. So the next one is path analysis. That's where you have the mediation and the moderation model. Path analysis. SEM enables researchers to investigate direct and indirect relationship, direct and indirect effect or relationship between variables. So direct relationship is effect of IV on DV, and then the indirect relationship can be effect of IV or the relationship of a particular variable on the effect of IV and DV. And then, so it supports mediating and moderating variables. Supports mediating and moderating variables and chain effect of analysis that reveals how and why variables are related. So for a structural equation model analysis, you get to see that this particular mediating and moderating models are captured effortlessly. You don't just get to do a straightjack analysis. You can decide to moderate your model or mediate the model. Another application in research is modeling latent variables. Excuse me. Many psychological, social, and behavioral concepts, such as intelligence, trust, and anxiety, cannot be measured directly. I mean, if I ask you to measure intelligence now, how do you do it? So you cannot measure it directly, but SEM allows researchers like us to work with latent variables using multiple indicators to capture abstract concepts. So if we talk about intelligence is a latent variable, but then you can use multiple indicators. Those statements in your questionnaires are what we call indicators. Yes, please let me put that very straight. Those statements in your questionnaire, so you can say, okay, we want to measure intelligence, and then you make a statement like, any student that scores his test 7/10, that means that child is intelligent. Or a student that can present this particular seminar effortlessly without any fear or without having to consult his material from time to time, that means that student is intelligent. All of those statements in your questionnaires, you use those indicators to measure the latent variable, intelligence. Trust is another latent variable. You cannot measure it directly. It can be trusted. So you can now say, oh, how do we measure trust? You can, let's say, amount of money to keep for 1 year, and then the person returns the money complete. That means the person has some level of trust. Or we can hand over this document to this person, and then it's safe with this person. That means we can trust the person. Different indices we can use to measure trust. But all the same, structural equation modeling helps us to model latent variables with indicators, multiple indicators that can actually capture the concept. Multi-group comparison. Structural equation model is used to groups. Example, gender, age, and country, making it valuable for cross-cultural or analysis. Please, if I'm too fast, you can call my attention in the comment section, and then I will take it slow, and then I will get to refresh whatever I'm saying. Okay, types of structural equation modeling. There are basically two types of structural equation modeling, namely covariance-based structural equation modeling and partial least square structural equation modeling. So covariance-based structural equation modeling focuses on theory testing and model confirmation, aiming to reproduce the observed covariance metrics. I mean, this may sound a bit very stressful for people that are just new here, but when we get to hands-on, you will get to understand. Now, covariance-based in a very simple way, covariance-based is used for when you are doing the CFA, yes, the confirmatory factor analysis. That's where you use covariance-based structural equation modeling. But partial least square structural equation modeling is designed for prediction and exploratory analysis, emphasizing the maximization of explained variance independent variable, the effect of an independent variable on the dependent variable. So what we'll be doing today on hands-on will be SEM, partial least square structural equation modeling. Next slide. When to use partial, excuse me, when to use partial least square structural equation modeling. Now, when the goal is prediction rather than theory testing. First of all, when your goal is to predict the effect of an IV on a DV rather than just to test a particular theory. Like I mentioned, this the CBSEM, covariance-based, is for theory, while this BLSM is for prediction of relationship or effect of an IV on a DV. Now, when using formative constructs, if the model includes formative measurement constructs, where indicators from latent variables, where indicators form latent variables, PLSM handles them more effectively. So when you are looking at formative, measurement, you use PLSM. PLSM is the best and the appropriate tool for every kind of this type of analysis. The next one is when the model is complex. I've said this over now. I've said this before now. When the model is complex, when you have a complex model, a mediating, moderating relationship of an IV on a DV. I've actually seen a model that there was a mediating relationship of the IV on the DV. There was also a moderating relationship of the IV on the DV, and then there was a moderating relationship of the mediating variable of the IV. Like the IV is they are trying to moderate the relationship between the IV and the mediating variable. And when I saw that model, I was wow. But then I went through the analysis and I saw that the researcher actually used SEM to actually do a very neat analysis, and the result was very clear. The objective was achieved and it was explained clearly. It was interpreted in such a way that if you read the work, you'll understand and you will know where the researcher was. In structural equation model, we have the latent variable and we have the observed variable. These are two concepts you will hear most often. Latent variable are those things those variables we can call independent variable. Yes, independent variable. That would be a bit easy for all of us to understand. While observed variables are those variables are those ones I call the indicators of the latent variables. Those statements in the questionnaire, those statements you use to measure a particular variable in the questionnaire are the observed variables. Another one is the reflective and formative construct. Now, in reflective construct, the latent variable is assumed to cause the observed indicators. Changes in the construct leads to changes in all indicators. That's for the reflective construct. But for the formative construct, Formatives are formed by their indicators, meaning the indicators cause or define the construct. The indicators, that's the statements in the questionnaire, they cause or they define the construct, that's the Latin variable. Now, these are the basic concepts you will get to hear as far as structural equation modeling is concerned. When you hear Latin variable, observed variable, reflective construct, formative construct. Okay, the next one is measurement versus structural model. This is another concept you hear, measurement and structural model. The measurement and structural model are two key components of structural equation modeling, each serving two different purposes, serving different purposes. The measurement model specifies how latent variables are measured, by their observed indicator. That's the measurement model, and you'll get to see the structural model. So the measurement model specifies how latent variables are measured by their observed indicators, focusing on ability and validity of the relationship between constructs and their corresponding items. I had mentioned this before now, that the measurement model focuses more on the validity and the reliability of your research instruments, of the items in your research instruments. How valid is your instrument? How reliable is that instrument? While the structural model defines the relationship among latent variables, showing how constructs influence one another based on their theoretical framework. So the structural model basically tells us the relationship or the effect of the IVs on the DVs, the moderating variables as it moderates the relationship, or the mediating variable as it mediates the relationship between the IVs and the DVs. That's the structural model. The structural model is actually the part diagram that we will see. But the measurement model is the one that gives us a detailed insight of how our instrument is, whether it's actually reliable or whether it's actually valid. There are so many softwares using structural equation modeling analysis. The most popular one is SEM. Is EMOS. We all know EMOS, analysis of moment structure. That's very popular. Most people that have done SEM before now, EMOS have been our savior. EMOS have been the foundation. And then another one is LISREAL, analysis of structure relationship. We have M+, yes, we have EQS, we have CALIS, we have R. R does structural equation model also, yes. We have Stata, we have Tetrad, we have MX, we have SEPAT. All of these are softwares. Then we have Smart PLS. The one we are going to be learning today, where it's used in doing a structural equation modeling analysis. Okay, so I think I will not do this because of time. Brief history of structural equation model. Brief history of Smart PLS, rather. How it all started, with who, Christian Ringel, Stephen Windy, and Alexander Wills. These are the brain behind Smart PLS. They're the ones that actually came up with this software. They designed it, and then every single time they keep upgrading. The first time I met Smart PLS, the interface we have now wasn't the interface. They've added so many things to this software, and they keep making it formidable every year. And that's why Smart PLS, I would say, is my best bet for now as far as structural equation modeling is concerned. So key features of Smart PLS. It has a user-friendly graphical interface. We'll see it. All of this will see it. Support for reflective and formative constructs. Bootstrapping and resampling techniques. We'll see all of this. Model evaluation tool. Mediation and moderation analysis. We have multi-group analysis, higher order construct. All of this, when you open the software, the homepage, you see some of these features. We have the prediction oriented assessment, importance, performance, map analysis, data handling, flexibility, export and reporting option. You can just at a click export your output down to the Microsoft and then start your reporting. So thank you for listening. But please